Now recording. Maybe just zoom in a little on the screen. I think the people watching at home will appreciate that. Oh, no, stop it. Stop it, you. You're supposed to go up. There we go. That's as good as it's going to get. There we go. So, some of you may have noticed that in the announcements feed, the day and time for our final examination has been made available. We will be having our final exam Tuesday, August 12th at 2 p.m. in room A222. Save the date. So, nothing really much to say aside from that. Aside from the exam will be a 3-hour affair. I'm sure you've written exams before, so this one will smell pretty similar to previous ones. So, good. Any questions? Any questions about anything? What assignment are we working on at the moment in this class?
The next assignment, it's going to be lab assignment 3.
Assignment 3, that's due July 25th.
Yep. So
Okay, so we still have some time.
Mm-hmm.
Yes. Any questions about the assignment? Is it going well? Have you started? Anybody started the assignment yet? Yeah? Is it going okay?
Decently.
Decently. Okay. Good. All right. Sounds good. Just sessions, you know? Just sessions and some programming. That's most of it. So, let's keep going with our example that we were doing then. So last week, on Monday I think it was, Monday or Tuesday, whatever our previous class was, we were working on this big building example where we were doing a login credential system. Now, I'd like to continue expanding on that, and we're going to use this example as a motivating example next week when we talk about MVC, Model View Controller Architecture. We're going to take a look at our code and say, oh, this is really awful. Wouldn't it be nice if we just cleaned it up this way, cleaned it up that way? And that's how we're going to discuss MVC, by transforming this thing into something that's nice. So, if you could get XAMPP up and running, please launch your Apache and SQL servers. Let's put our database back in order. Now, if I recall correctly, we called this database YOYOY. There we go. We need a credentials table. Credentials table. We had ID, which was an auto-incrementing primary key. We have username, which will have the unique constraint. Password, which will not have the unique constraint. Both of those are varchars.
What's the index name for username?
If you just click OK, it'll fill in defaults and that'll work. And then we also had name, which is real name, I guess. 64. Sounds good. If we save, there we go. Our credentials table is created. Very good. Next, let's make sure that our code still works. So, if you don't have the code from last time, please go to the announcements feed. Thank you. Whew. Please download the zip file that is attached to the announcement today's code from July 14th. This is the code that we were working on last class. Please download that and extract the archive into your htdocs folder, such as I have done. Once you've got that done, check to make sure that you can still access it. Localhost 1080, or whatever your port number is, and call up the folder that you stashed that in. And there we go. So, at the moment, things look a little bit on the basic side. It's not really easy to tell what's going on here. So, let's modify our index page.
One thing you can do is you can just, if you have all of them and you click open, you can open all of them simultaneously.
Yes, true. Boom. So in the index page, basically, just to review the structure here, the first thing that we're doing is we are opening up the session, but only if the session hasn't already been opened. Recall that scripts such as log in and log out include the index page as the last thing they do. So, these scripts will already have set the session up. If we try to set it up twice, we get a warning. So, to avoid the warning, we check to see if the session superglobal has been set in index, if not is set session, and then we start the session only if it hasn't already been started. Does that make sense? Another way you can approach this type of thing, you could take the session connection code and drop it into another file. And you could use the include once compiler directive. Include once is different from include. There's also require once, which is very similar to require. The difference between include and include once, anybody care to take a guess? It's fairly straightforward from the name.
Does it includes once?
It only includes it once, that's right. So if you attempt to include something multiple times when you've specified include once, it will only do it once. This is very useful when it's startup code that, startup code of this nature. Does that make sense? It's like, this also does the trick though, so let's just leave it the way it is. Here, we are detecting if the session has a parameter logged in and it's true, we show a welcome screen, which is the, this is the page that is, this is the page that we're showing once the person is logged in. This has like your secret information in it that you don't want anybody else to see. This is your banking information, etc. Otherwise, we prompt for the login page itself. Making sense so far? So far, so good? Very good. So, let's just make this a little bit, a little bit more HTML-y. I suppose I used up H3 up there, right? Please log in to YOYOY. I know this isn't the proper way to do it. The proper way is with labels. There we go.
Sorry.
Yeah.
If you wrapped the whole thing in divs, would it make the line breaks unnecessary?
If I wrap the whole thing in divs, would it make what unnecessary?
The line breaks. Instead of BR, just wrap the username, password, submit in a div. Would that automatically apply a line break?
I believe if you put the form inside of a div, you wouldn't get line breaks here. Like,
No,
unless
not the form, the content of the form.
the content of the form. Oh, I don't know. I've never tried. We could try it. Yeah, I suppose it would. Like you can use divs to, like when you separate things with a div, I do believe it ends up on a new line, doesn't it?
I think so. I mean, I did it once accidentally. I'm not exactly sure, but it just came to mind.
Yeah.
Yeah, I want to try it right now. Actually.
Yeah, let me know how it goes. But there you go. Looks a little nicer.
Oh, okay.
Yeah. So, at the very least, we now know what it wants, right? So the difference here, right? Well, the principle of user design that we're now enacting is a very important and basic one. If you put a form element on a page, it should tell the user what you should put in it, right? You should never have form elements where it's not labeled or mysterious what the operation is, right? So, good. So far so good. So we have login and logout scripts done up. Let's review the contents of the login script quickly. So, we start the session, obviously. We require connect.php. This is the code which we've stashed our connection to the database information in. So that's all good. 5 marker one just isn't working out. We are acquiring username and password, which are past post parameters. These are generated by the form that we just fixed up. We then have our query, select password from credentials where username is equal to question mark. The question mark is filled by this parameter here. When we execute the execute method, we pass that all of the variable values that we want to be substituted in everywhere we have these question marks. If we had 2 question marks, we'd need two things in this list. If we had 3, we would need 3, etc., etc. So it's an important point, but when you're working, like when you're teaching a computer to access a database autonomously, which is what we're doing here, it's a little bit different from doing it, yourself sitting down in front of, MS Access or something, right? The computer should, these are good principles when you're working with databases as well, but even more important when you're teaching a computer how to do it. You should try to never see unnecessary data, right? You should always try to use the filters available to restrict your search to only that information which is necessary to perform the operation you are trying to perform. So in this case, it would be possible to gather every entry in that whole credentials database, right? Pull it into PHP, sort through it using a for loop, pull out the entry we're interested in, analyze it, etc. But when we do this in our PHP, probably the best search that we're likely to implement is a search algorithm called linear search. Have you guys heard of linear search? Yeah. As opposed to binary search. Did they talk about binary search?
Yeah.
A little bit? So, the data that we're going through probably isn't sorted. We could order it, but maybe we could do binary search. But the database has really super hyper fast search algorithms built into it already. Databases are hyper optimized for exactly this type of work. So it really doesn't make sense to re-implement that searching function yourself. Not to mention, when you pull an entire table into your script, you have to store all of that data in the memory system of the server. Now, when you are paying for server time, which you will be most of the time, you are paying for a couple of things. One is disk storage, that is to say, ROM. Another one is memory, RAM, random access memory, right? So, if you keep your search restricted to just a couple of parameters, you will also save yourself actual real money. Make sense? So that's why we've configured configured this way. From here, we are checking to see that the password that was passed is equal to the one that we fetch from the database, using a fairly simple if statement. One of our objectives today is to make that a bit more complicated. We're going to introduce hashing. As for logging in itself, what we consider being logged in is having a logged in variable set inside of the session. Does that make sense? This means that logging out is extremely simple. All we do is unset the session, and there you go. Does that make sense? Any questions? Good. So, there are two more functions that oh, sorry, you did have a question, yes.
Yes, can I see the index PHP?
Certainly.
Thank you.
So for further practice, implementing these database functions, let's do new user registration, right? So in order for this to be useful, we need a way of registering new users. So let's throw a form in there for user registration. Log in existing user, and register new user. So, by the way, on the subject of registration versus, all of that stuff. I'm sure all of you are aware of GitHub, and good. So I just want to call to your attention one thing about the design of their homepage, right? Sign in, sign up. What is the difference between these two buttons?
Sign up means to basically create an account, and then sign in means you basically log with an existing account.
Though that's the difference in the functions, but what about the actual buttons as they appear? What's the difference?
One is outline,
One is outlined and the other isn't. Which one is outlined?
sign up.
Which is the creation of the new account,
Which
right?
attracts your attention more.
Yeah, so the idea, and you'll find this, this is quite a universal thing across websites now. The sign up or registration button is really big and prominent, and the sign in isn't, right? There's a reason for that. That's an intentional design choice. Even for a website like GitHub, most of the people who visit the website won't have accounts, right? This is the observation that they've made. Most of the people who are visiting your website will not have an account. So, making it easy and obvious for them to get a new account is more important than making it easy and nice for people who already have an account to sign in. People who already have accounts, assuming it's not an account they made once and then abandoned, right? People who have accounts who actively use your service will have seen this page a few times and will, through memory, remember where the sign in link is, right? So it's not as important that you service them with your user interface design. Much more important to call out to the people who don't have accounts. Does that make sense? Good. So registration then. In our case, that means that we should probably put registration above logging in, right? Although, always keep in mind that the area that your user will first look at is approximately 1/3 of the way down the page. That's where the eyeballs hit first, right? So, for registration, we can largely copy over the form as we used it for login. Register. We only need a couple of differences. Number one,
Register.php.
register.php, yep. I see you're ahead of me. Second of all, when you're registering an account, very often they have you re-enter your password, right? Now, really, in production code, what you would do is you would handle that on the JavaScript side of things, right? That would be a client-side check. But in our case, let's pass that through to the server, because this is server-side programming after all. So we will call this password 2, password 1 and password 2. There we go. Very good. So, having set up our new form, let's take a look at see how it looks. There we go. We have register new user and log in existing user. Very good. Now, let's make our new PHP script. Register.php. Now the wonderful thing about database access, once you've got it working for one function, it's quite easy to continue that pattern and get it working for more queries, right? Most of the code is copied over in most cases. It's not plagiarism. It's not plagiarism to go log in, copy, paste, right? We are modifying the existing code rather than drawing it up from scratch. So a few short seconds ago, we changed what the input post parameters are for this script. What did we do? Anybody remember? Shall I show you the form again? How is this one different from this one?
Passwords have different names.
Yes, and we have two of them. Very good. So, we have now password 1 and password 2. We can call those P1 and P2. Very good. Now, the query, of course, is going to be entirely different. But before we even get there, let's, right up front, do our check to make sure that the passwords are the same. Now, a thing that I kind of skipped was the null checking on filter input. I'm going to skip it again. Put it in on your own time, please. That's homework. So, if password 1 is not strictly equal to password 2, echo password mismatch include index.php, show the page, and exit 0 to terminate the program. Make sense? Test early, test often. Let's test that out. So, username, yes. Password, yes. Re-enter password, no. Register, password mismatch, and we're back to this screen. There you go. So far, so good. Any questions? Good. Now let's discuss how this query changes. If we want to register a new user in our credentials database, what sort of SQL query would that be?
Insert.
That was the answer too.
Yeah. All in favor of insert?
Yeah.
Very good. Insert it is. Now, remember my advice. When you are formulating insert queries for these databases, if you go to the SQL tab and click the insert button, it gives you a template. I think that using this template is intelligent. It's sometimes difficult to remember what requires the backticks, what requires, string quotations. So this is just, templates are good. Use a template. I'm not going to be one of those people that says, no, if you don't do the whole thing by hand from memory, then you're not a real programmer. There we go. So, now, The first thing I did was remove ID. Can anybody tell me why I just removed ID?
It's auto-incremented.
It's auto-incrementing. It's already being put in. We don't need to put it in ourselves. Very convenient. So, each of these values will be something that we have to supply. Now, we are receiving username, that's good. We are receiving password, that's good. What are we missing? This thing.
Yep.
We're not currently gathering any information from the user to supply that field. It is not appropriate for the PHP script to guess what your name should be. You should ask for it. So, let's go back to the index page. Add one more field to supply that value. Name is equal to name. Ugh. Now, going back to our register script, we must filter and sanitize the name as well. Very good. This is your first layer of security. This is your second layer of security. So now, we need to provide username, password, and name. Username, password, and name. For password, we've already checked to see that P1 and P2 are identical, so it doesn't matter which of the two we choose to put in here. Did you have a question?
Yeah.
What is it?
I was actually going to ask why not P2 more.
Oh, well, there you go. Good. There we go. So, any questions so far? So this is a query where we're not expecting to see anything back, right? All we are interested in is registration successful, registration unsuccessful, right? So all of this code here not useful in this case. We can instead echo registration successful, or sorry, you're not cool enough to have an account here. Actually, an SQL error though. You don't have to write that whole thing out. So, shall we test it? Save. So, register a new user. Oh, wait. Let's just, oh, uh-oh. Someone forgot a semicolon. Where did I forget a semicolon?
Registration successful?
Ah, thank you. registration successful. And let's see if that's true. Boop. There we go. So it works. Now, let's see if we can log in with that same thing. Username is Felix, password is bunnies. There you go. Login successful. Log out. And there you have it. A login system with registration. So, at this point, I'm going to leave deregistration as an exercise to the user. However, I will revisit the idea with you now. Whenever your user is performing major account changes, it is good practice to ask them for their password again. If their session has been hijacked, the very first thing that the attacker is going to try to do is perform a major account change. Most typically, changing the password on the account. If you do not require the user to re-enter their password to change their password, then anybody who's hijacked the session can change that password, lock the poor victim out of their account, and that's it. You're off to the races. You can start booking yourself your 3 weeks vacation in the Bahamas on someone else's credit card. Right? So, when you're doing account destruction, that's another thing that you should keep in mind. Ask again for the password. If you want, as an exercise that you guys can do, this week for practice, changing your password is another, have a little password change form. That's also that's a good exercise to practice this stuff. Okay? But, I would like to move on because we've got cryptography to talk about. Yes?
Back to the index form.
Yes, my good man.
Sorry, login. Is it login? Yeah, it's login. For the register, register. So you said the field sanitization, that's the first layer of security. And then you said the second layer was the execution.
Using the question marks here to take these parameters and put them in safely rather than splicing them in ourselves.
Oh.
This protects against SQL injection attacks.
I was about to ask that.
Yeah.
Because one time I ChatGPT thing and asked it to explain it to me and then said that line prevents injection. How?
So, basically, execute is doing a lot of checks behind the scenes that that it doesn't tell you about, looking for things like SQL control characters, looking for it, trying to comment out your stuff, all of that kind of thing. So, you guys want to see how an SQL injection attack works then?
Please.
So, before I do, let me just say that this would be the SQL injection attack vulnerable version of this line.
Even though those things are already sanitized.
Well, they're sanitized against XSS attacks, right? These have been sanitized against JavaScript-based attacks, but JavaScript control characters and SQL control characters that's a different set of things, right? It's always good to have multiple layers of security. valid characters will be valid according to both filters. So, don't do this. This is bad. Right?
Yeah.
So, let me explain how. Well, I'm going to use this query actually, it demonstrates it a little better. So let's imagine we have a nice little SQL query. Select star from credentials where username is equal to username. Sure. The question is, what values of username can we put in here to do some damage, right? Now, let's say we had, well, in the nominal case, of course, we have something like username is equal to an actual username, right? Which means that this part becomes something like that. You can put the ticks in. That would be like, I think it's unnecessary actually. So, well, I think when you do execute, it'll put the string quotes in for you. But when you're doing it manually, like you'd have to put quotes in like that, because it's a string, right? And of course, that means this one would have to be, those would have to be escaped probably. So this is actually escape character quote, $u, escape character quote, semicolon, right? Good. So substituting in this, we get that's our string. So far, so good. Now here's an interesting little thing, right? What if username is, for example, the following? Not and. You don't need that. Gotcha, or 1 is equal to 1. So is 1 equal to 1? Trick question. 1 is equal to 1 every day of the week. I sometimes put these into my programs because I want to know if 1 is ever not equal to 1. Because if 1 is not equal to 1, I'm gonna like go and buy a $10 billion mansion because numbers don't work anymore. So if you take this, so what's anything or true?
First will just be taken.
No, that's and, right? If I have true or true, what does that yield?
That's true.
What about false or true?
True.
So in effect, or true is a way of taking whatever the first thing was and ignoring it. Right? So if we substitute that in, we get username is equal to gotcha. I'm gonna space characters, or 1 is equal to 1. There you go. That's now the end of that query. So, rather than getting one entry out of that database, we're now getting all of the entries out of that database. Right? So that select query is now, like we've broken the select query. It's now disclosing everything, right? It'd be difficult, but if you combined this with a man-in-the-middle attack, like if you could crack the network traffic at the same time, you could get all of the username password combinations as they're being sent to the server, because this is going to trick the database into giving the server the entire table, right? Which is, even aside from like the data loss potential problem, there's also a potential problem there just in like you can take a server down by putting too much traffic on it, right? This would be one way to do that. Are you familiar with the concept of the distributed denial of service attack, the DDoS attack? Anybody not know what a DDoS attack is? Yeah, well, this is like kind of in that ballpark, right? But we could think of even worse ones, all right? How about this lovely piece of nastiness? No. So, I'm even going to use my red marker for this one. So this one, the only purpose of gotcha here is to finish the first statement in a way that's syntactically correct. Because if you introduce a syntax error, your attack has failed, because the server will bork on the syntax error, right? So this becomes username is equal to gotcha, semicolon, statement separator, drop table credentials. It might take you a couple of guesses to get the table name right, but normally people name them like standard things, right? Semicolon. Does anybody know what the double dash does?
Comment.
Yeah, it's a comment. So the final quotation mark and semicolon are commented out. So you've commented out the rest of the query, right? So drop table credentials. If your system is configured that it will execute multiple queries in one request, which is a thing a lot of them can do, right? You can just destroy the entire table, right? Just like that. And depending on your service, that may or may not be backed up. That may not have been backed up for a while. It really depends, right? Now, that's kind kind of a extreme data loss scenario, right? Just trust me when I say there are clever ways to be able to extract data as well, right? But this kind of should give you the flavor for how you get SQL injection to operate, right? So SQL injection is a code injection attack. As with all code injection attacks, the goal is for the attacker to get malicious code to execute on another machine as if it were legitimate code from a legitimate place, right? This is the same principle that cross-site scripting attacks work on. The cross-site scripting attack is a JavaScript injection attack, right? It's like a specific type of JavaScript injection attack, right? Like in theory, in theory it's only a cross-site scripting attack if you manage to get like a JavaScript source file from some other part of the internet to execute on that person's web page. Technically that's what's meant by cross-site scripting. But you can do just a plain old JavaScript injection attack, get some JavaScript executing on someone else's computer. You could do a keystroke logger, for example, without needing to run an external script. The thing about running an external script is that it hides what it is that you're trying to do and where you're sending it to, right? A little bit anyway. Once something is on the client, then you know where it is. And if you're doing this sort of thing and you're not using like multiple proxies and VPNs, you're not a very good hacker. But yeah, does that make sense? SQL injection? Any questions about SQL injection? No? Yes?
Does that happen when someone is trying to register?
It can happen in any field on any form at any time. All you're looking, if I put myself in the position of the hacker, all you're looking for is like a soft part where the security's weak, where they've forgotten to do something. What this query is doesn't really matter that much, right? Especially if I can get my own queries appended to the end of the query string. It doesn't really matter that much whether it's the registration or lookup or anything like that. If I can run my own queries, I'm in. Right? That's kind of the whole strategy is find the soft underbelly and thrust the bayonet. So yeah. Any other questions? So, multiple layers of security then?
Yep.
Yeah. So. So on the subject, this is just a small tangent, but so most of the big data losses that happen, most of the internet attacks that happen and are successful are SQL injection attacks. They're like the biggest and the most damaging, like on average. Ransomware attacks are really coming up though. Do you guys know how a ransomware attack works?
The gist of it.
Give me the gist.
Basically, they usually either hold something captive and demand payment for it.
Mm-hmm.
Although it depends if sometimes they actually follow through with their promises, sometimes they don't. They usually also in there and promise that if you pay X amount of whatever, they'll set everything back to normal. So the fact that you are
So, do you know what they do to capture your computer? Anybody?
It could be on phone, usually they will,
Well, let's assume they have, what did you say?
Fishing?
Phishing? Yeah, that's kind of their point of entry, sometimes. But let's assume they have access. What do they do to your computer to lock you out of it?
I assume you have like a file where you can run PowerShell and just inject that into the command line.
But like, what do they do to your files once they have shell access?
They encrypt them.
They encrypt them. Yes, that's what the ransomware attack is, right? They take all of your lovely, lovely precious data and they encrypt it. They encrypt it using a secret encryption key that only they know. And they say, listen, guess what? You give me $50 million, $1 million. That might be a reference that's too old for people now. And I will give you the encryption key that will unlock your stuff. And that's kind of, that's the ransom part of the ransomware attack. Of course, in order to get into that, they have to be able to encrypt your hard drive, which means like they have to have, basically root level privileges. Like, you need to have gotten hacked real hard for a ransomware attack to happen, right? So here's an interesting thing I want to show you. Let me show you. Is this Firefox? Get out of here, Firefox. So there's this interesting little graph, right? This is the TIOBE Programming Community Index. This is basically a measurement of how much people are searching various topics within various programming languages. So this is kind of like a good measurement of what's being taught in schools, but also like what people are generally interested in. This is not necessarily usage. It will probably correlate with usage, but it's like if you want actual usage, you should check something like the Stack Overflow Developers Survey. But I just want to point out this little line here. Come on, the red one. There we go. Red one. There we go. Visual Basic. Visual Basic. Very low level, not a very popular language until a little bit into 2020. So, do you know what Visual Basic is used for? What its primary application is these days?
Isn't that an editor?
Visual Basic?
Visual Basic. What did you say?
Isn't that an editor?
An editor?
Yeah.
Yeah, it's got yeah, you can make form applications in it, kind of similar to C#. So yeah, there's Visual Basic for standalone application development. That's not its primary. That's not what it's used for primarily, though. That would have been the case back in the 90s. Anybody? Anybody know what VB is for?
Not anymore.
Office macros. Microsoft Office macros are written in Visual Basic. So macros for Excel specifically, because Excel, it's kind of already fairly programmy, so macros are useful. But also macros for Word and PowerPoint and all that kind of stuff,
Yeah.
right?
Yeah.
Macros. It was discovered right then that you can perform a ransomware attack using Office macros. So,
That's
interest in the language shoots up overnight. And it's because it's like, ooh, I could use this to hack someone. Oh no, this could be used to hack me. Right? So there you go. Current most popular language in terms of this index is Python. Second is C++, if you can believe it. Close third is our old, good, humble friend C, the C programming language. And Java. Oh, poor Java. The tale of Java is a tale of slow but steady decline since the 90s. And this one is C#. C# is not as popular as it used to be. JavaScript. See, I would expect that to be higher on this index, considering that's the most used programming language in the world, right?
Yeah.
But, yeah, I don't know. Of course, I wouldn't expect, like, Delphi/Object Pascal to be on this list either. That's just kind of an interesting little, that's an interesting little story there. So, I'd like to tell you a tale of misery. Let's talk about password security now. So, there is a thing you should never, never ever do, and that is store passwords in plain text anywhere. Right? What does it mean to store a password in plain text? It just means that the password is the password, it's not encrypted. The degree of security that your password has is basically the time delay it takes for a hacker who has acquired your password's your hashed value, the time it takes for them to get your actual password out of that hashed value. That's what the quality of your hashing is. But let's talk about a couple of different topics before we sort of get into it. So, we know what encryption is, right? Everyone knows what encryption is? Anybody want me to run through the concept of encryption quickly? Sure. Okay, so let me tell you, let's draw our minds all the way back to the Roman Empire, all right? The Caesar cipher is the first kind of notable use of encryption in human history. And it was invented by Julius Caesar, purportedly. So, basically, in the Roman Empire, they had a problem where military messengers would be delivering very, very important messages and notes on horses, running through the countryside. The problem is, the enemy is also in the countryside. If your messenger is attacked and killed, and the message taken, and your message says, "We attack at dawn," then the enemy knows you attack at dawn, and you have lost the element of surprise. So, the Caesar cipher was invented to prevent people being able to read captured messages. If you have a short message like this, the way the Caesar cipher works is you take each of these letters and you replace it with one letter 3 letters down. So, A, B, C, D, 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 T, T, U, V, no, U, V, W, 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 C, D, E, F, that's right, and K,
L, and N.
N, yes. So you can see, you know, if you're an Ostrogoth, that doesn't really make a lot of sense, even if you know Latin, right? So, very good. This is a very early example of something called a substitution cipher. Substitution ciphers are the types of things that you now find in newspapers for people to crack for their own amusement, right? As mathematics develop, it's found, oh, well, this is good if you don't know the secret, but if you know the secret, there's no, you know, you can crack this very easily, right? So, we develop a kind of, a new type of encryption which requires some additional piece of knowledge, an encryption key. So, if we take some information and we scramble it, but that scrambling process requires another number, that is to say an encryption key, unless you know the encryption key, you can't reverse the encryption, right? It would like you can crack it, but it takes a very long time, right? Another historical example. Do you folks know what the Enigma machine is?
Mm-hmm.
Yeah. What's the Enigma machine? I'll bring up a picture of it.
It was basically a method used by the Nazis in World War II, but I believe mainly the German Navy, although I believe the Army and maybe the Air Force used it. It was basically a method of communication. So what would happen is a ship would receive. Okay, the way it worked was there were basically 3 rotors each with every letter of the German alphabet.
Yes.
And what would happen is, every time you would press a button, the machine would rotate, and when you press a letter on the keyboard, it would light up a different letter. However, one thing that made it really hard to crack was that you could keep pressing the same letter over and over again, and you would get different letters encrypted.
Mm-hmm.
So obviously you need the original settings of the Enigma machine in order to properly communicate.
Yes. So the Enigma machine, you have 3 rotors here where you can dial in what your number is supposed to be, what your combination is for the day, and the Nazis would change. Like they had a list of rotor positions and they were secret. Every day they would change the rotor positions. The positions of the rotors, those are the key in this form of encryption, right? So once you had your rotors in position, you had a keyboard, you would type out the message, it would make different lamps light up that would correspond to the substitutions that the rotors were making. But it was a little bit more complicated. It wasn't just a straight substitution cipher. As you typed out the message, the rotors were also rotating at the same time. So basically, it's like, every subsequent character was using a different set of substitutions. And so it's a substitution cipher where every character in the encoded text uses a different set of substitutions. Right? Very, very clever. The Nazis were very clever. And basically, the British, they had a unit in military intelligence, and their only job was basically to play cryptograms all day to try to decode German messages that were sent. Because the thing about these messages is, the reason they were doing this is they were broadcasting these messages via radio communication, right? Radio communication means anybody can hear it, right? Including your enemy. but they were relying on this thing to prevent them from, knowing what was being said. Yes?
So you know that there's also another encryption, the layer of encryption, which was the plug word, which would basically, I believe it was somehow connect one letter to another.
Yes.
Yeah, so.
Yeah, it was we don't need to, get into all the details, but, it was a very, as encryption goes, like, this was the fanciest friggin' thing that human beings had ever developed. And in order to crack that thing, it required building basically the first electronic computer by Alan Turing during the war. And anyway, there are movies on that if you want to go watch them. But basically, that's like the idea here is that this is encryption with additional parameters thrown in that are secrets, right? That mixes things up. You can't get it back out again. But the thing about all encryption is that it is reversible, right? If I know the key, I can reverse the encryption and read the original message. Make sense? Otherwise, in a ransomware attack, there would be no way for the attacker to offer you the thing that would fix your computer. Your computer would just be, permanently buggered, right? So, that's encryption. Hashing now. Let's talk about hashing. So, unfortunately, hashing is one of these types of terms, concepts, that means different things depending on who you're talking to, even within the field of computer science. Have you folks heard of a hash table? That is a different thing from what we're talking about, although a hash table also requires hashing, right? You folks have heard of hashtags, right? Yeah. Hashtags take those tagged strings and hash them, and that interacts with a database somehow. That's also not really quite what we're talking about here. So what we're talking about is cryptographic hashing. So the difference between hashing and encryption is that in hashing, you still require a key, right? And you still need to know what your, hashing algorithm is. But the big difference is there's no reverse hash algorithm. Encryption is bidirectional. You can encrypt and decrypt. With hashing, you can hash, but there is no unhashing. And this has to do with mathematical stuff that we don't necessarily have to get into. But it has to do with the modulus operator. So let's say I have x. X is any number. This is a simplified example. X is any number. Let's say my operation is mod 2. Right? This means I take a space of x's. Let's say it's the same as the natural numbers. Right? You guys know what the natural numbers are?
I don't know the exact definition of it.
It's fairly intuitive. It's the numbers as you learned them as infants, just including 0. So 0, 1, 2, 3, 4, 5, those are the natural numbers, off to infinity, right? So we've got the natural numbers. This is being mapped to a much smaller set containing only 1 and 0, right? So, given 1 or 0, how can you tell what number x was?
If it's divisible by 2.
Well, half of the natural numbers are divisible by 2. Which one? Right?
You'd have to use the numbers around it, no? Like the other zeros and ones around it.
Let me write this in terms of a formula, alright? Let's say x is equal, let's say we don't know what x is, right? But x mod 2 is equal to 1. Is there any way to solve for x?
If x not 2 is 1, addition for x.
Think about all of the possible values of x which would satisfy this formula, right? X could be 1, it could be 3, it could be 5, it could be 7, all the way on down to infinity. There is actually an infinite set of numbers that x could be. There's no way to determine a value for x, right? And that means that this modulus operator, it goes one way, but it doesn't go the other. This is how hashing works. Hashing goes one way, but not the other, because it makes use of modulus operators, generally in a general sense. Maybe some of them don't, they use other things, but a lot of them use modulus because it's easy, right? And we have circuits in our CPUs that already do that, right? So, does that make sense? Irreversibility of a mathematical operation?
Yeah.
Another way of thinking about it is that when we take mod 2, we are losing information, right? We're losing information about the number. This is not true with something like multiplication, right? If you multiply a number by 5, you can get the same number back out again by dividing by 5. You haven't lost any information, right? But if you perform modulus, you are severely restricting the possible values that it can have. You are in fact you're losing information, right? It's like a number theory point. Does that make sense? So, okay, so hashing. Okay, we want to hash. Sounds good, right? So, within the sort of history of the development of such things, there's been kind of an arms race going on. It's like, okay, at first we stored passwords in plain text. That was a terrible idea, right? We started in plain text. Terrible idea, broke almost immediately. Okay. Next, we hash passwords. Okay, good. Better. But, okay, so now it's just taking a little bit of time to break these passwords rather than them being completely secure. Again, there's no such thing as complete security. But, so here's a question, all right? Given that hashing isn't reversible, how can you use it? Let's say I have this in my password database. I know correct, like that's what it was produced from. If I have the string DEF, right, and I don't know about ABC, how do I know if this password matches that one? Because I can't just reverse this to get ABC back out, right?
We have to store that.
We have to store it.
Yeah, like whatever the input is, and another value like the has password. We have to store that both.
But if we're storing this, we're storing the password in plain text, which we should never do, right? It's true, if we stored that directly, we would be able to do this, but. So how do we take this and see if it compares to a thing that we don't know anymore?
You should be able to use the same key used to encrypt it to get the exact same result, which would be ZMP, right?
Exactly. If you use the same key to hash this value, and you get something different, for example, AM8, because we're using numbers now. You can compare the two hashed values. They're not the same, so it was not the same thing going in theory. In practice, there's actually a small set of passwords that all hash to the same value, but again, it's one of these things where it's like, cryptographically speaking, it would be extremely improbable for two passwords to ever hash to the same value. Not impossible, but it probably would never happen in the lifetime of the universe, right? However, if the thing that we hash was ABC, using the same process and the same key, we would get ZMB, which is of course the same thing. We test that, it matches, that must have been the password. Very good. This is the way that the server will check new incoming passwords to see if they match hashes in the database. It hashes them again. But with attackers, that's the same process they use to try to determine what the key is for the hashing. They, try a whole bunch of keys, try a whole bunch of strings. If anything matches a hash that they have in their big table of hashes, then they got you, and they got your password. So, okay, all right. So, just hashing things, maybe not. The next step in the evolution of this, it's a property of hashes that basically if you add any additional information to the string, it completely scrambles what the hash is supposed to be. So the next thing that we did is like, okay, all right, so I'm not going to hash ABC, I'm going to hash ABC _ Nick Rocks. There we go. I'm going to add to the string, right? You sort of have a magic phrase, right? This scrambles the hash completely, right? You have to know the magic phrase in order to reproduce the hash. The server knows that. Presumably, it takes anything that comes in from the user and it adds the magic phrase to it, right? It knows its own magic phrase. The only issue is, if that were to become known, then you're right back to square one again. It makes it much more difficult to break the hash, but once this is broken, you can break these real easy, right? This leads us to the current modern technique which is called salting and hashing. So, what if, instead of this being some magic string that the server just knows, what if this was itself cryptographically secure? XQ3V77Q, something like that. What if this was cryptographically secure, right? Already, this is easier, this is harder to break, right? Especially because these can be quite long. You could put like 32 characters in there if you wanted to. But with salting, this is different for every password. That makes it like much more secure. So basically what happens now with salting and hashing is like the server takes your crummy password and it adds to it a much better password, and then it hashes it and stores it in its database. Right? But of course, the problem with recovery is that you need to know the salt. Right? So the salt has to also be stored in the database along with the encryption key. Or, sorry, the salt has to be stored in the database along with the hashed value. So, you know, that weakens it. Basically, like, at that point it becomes a guessing game of where in this long string, where's the salt and where's the hashed value, right? But that's kind of where we are. So, let me show you how to do that in PHP. This was a lot of theory, and you will perhaps be disappointed by how easy this is to accomplish in PHP, given how much I've just been talking about it. So let's first talk about the registration part. So here's something to keep in mind, right? Changing the hashing on a database is hard, particularly if it's already being hashed. This is like a major operation. And, you know, a lot of companies, I'm sure, are using outdated and easy to crack hashing algorithms due to the difficulty and expense of taking a bunch of hashed passwords and converting them to a new hash, right? You know how some websites that you go to will get you to change your password like every 6 months or something? Well, they're probably taking that as an opportunity to update the hashing on your password as well, right? Because once the password is hashed, the whole point is the company themselves doesn't know, they themselves don't know what your password is. They only have the hash value. They don't ever store your password permanently, right? So they don't know your password. They don't know your original password, so they can't compute a new hash for it using a new algorithm. They have to wait for you to change your password. Does that make sense? Because then they know your new password again, then they can do it. Or maybe, you know, I suppose they could also wait until you log in and then use the password that you entered, but, you know, if you're not logging into your account, it is just sitting there with an out-of-date hash algorithm, I'm sure. So, the whole point is that when we are passing this guy in, P1, we don't want to pass P1 into the database. We want to pass a hashed value instead. Don't store the password in plain text. H is equal to password hash. There are other options that you can throw on this, selecting the specific hashing algorithm that you're using, that sort of thing. By default, PHP uses one called password default, which, for the purposes of this class, that's good enough, right? So, password hash the password. Now we put the hashed value into the database. Now, the password field is going to have to be longer now, right? In the database itself. Because the hashed value is going to be longer than 32 characters. So, structure, password change. Let's give that 128 just to be on the safe side. There we go. And now, having done only that much, let's try to create a new entry and see what happens. This also kind of takes you beyond the point where you can manually add a new credentials entry to your table, because you, a human being, cannot produce a valid hash, right? You'd have to run through the mathematics of the hashing algorithm yourself, and, why would you do that even? Because the computer can do that for you. So, if we go to here, password is, oh man, what does she think is funny right now? Her favorite thing is still painting. There we go. Register. Oh, sorry. It does want the second parameter. Let's take a look at the documentation. Password hash. There we go. Yeah. We'll just throw password default in there. Silly me, I thought that it would use the default by default. That's just a little joke. Alright, so we've given it password default. Let's try again. There we go.
So clean has password, right?
Oh, wait, did I
Oh,
put
there's
that in the wrong
password.
thing? I put that in the wrong thing. Good
Yeah.
grief. What am I even doing today? There we go. Registration successful. So, there we go. Let's take a look at our table data. Well, that looks difficult to crack. What would you rather have as a password in the database? This or that?
Bunnies.
Yeah, well, at least you can remember it, right?
There's a big, how are you supposed to remember all that?
You're not. You don't have to. The whole point is that when you log in, you enter your password and it hashes to that same string again. So, but it won't right now because we're not using that, right? We're not using hashing to determine the we're not using hashing on the passwords. In fact, now this entry should be deleted because it's not secured. There we go. So, let's go here and go to login.php. we must replace this bit. So password, as we're getting it from the database now, is a hashed password. We need to use password underscore verified. Password verified takes two parameters, the hashed password and the regular one. I suppose I was a little cavalier deleting that so quickly. So, taking a look at the documentation, the first of these two arguments is our password. The second is our hash. So, we put the password here, and the hash is the thing we are fetching from the database. Make sense? If you want to, you can pop that out into its own statement, just to make it a little more clear. Hash is equal to that thing. Hash matching braces is this. There we go. Gotta match your braces. That's probably a bit easier to read, a bit clearer what's going on. Make sense? Shall we see if it works? Let's log in. Cordelia, password is painting. Login successful. If I enter a password that is intentionally incorrect, such as poop, login not successful. Does this make sense? So, yeah, that's the long and the short of it. It's a lot of theory, but from the perspective of you, the programmer, you only need to use two methods, two functions, which is, it's pretty good. You should, though, if you have any inclination that in your future careers you will be doing any programming of this sort at all, you should understand security topics like this, right? You should dig into them a little bit, You should keep up to date on this sort of thing, right? Because, although it's nice to rely on libraries and that sort of thing to tell us what we need to know in these respects, you have to know what libraries to use. It's very important to stay on top of what the current security practices are for whatever language you're using. Particularly if you're using PHP, which requires you to call a lot of this stuff on your own. Things vary by vendor. Any question? Any questions?
Can't think of anything.
Good! Everybody's going to get 100% on the exam then? Hopefully? Yeah.
Can I see the code again, the last code?
Sure. That was in log in. Good. So, we've got 9 minutes left. In these 9 minutes, I will prep you a bit for next week, when we will be discussing MVC architecture. So don't pack your bags just yet, because I'm still talking. Never waste a moment of class, that's what I say. Except on tangents, because, I love my tangents. I love a good tangent. It's not wasteful. See, part of the purpose of going to a school to learn this stuff is to become enculturated as software developers as well, so that you can share a common culture. And in order to share in a common culture, you have to listen to me waffle on about stories about programming and stuff. There you go. So, model view controller architecture. It's like this example that we've been working through. It works, but you can kind of feel it becoming a pain in the ass, right? It's just kind of a minor pain right now, but you can see that the amount of ass pain that thing would be is actually proportional to the square of the number of things you're trying to do with it, right? The larger that approach gets, the more difficult it would become to manage, right? For example, right now, it's got a login page, and it's got a not the login page. What would happen if you wanted a home page and a login page? What if you wanted several pages within that thing? Are you going to have one gigantic series of if statements inside of the index page that all give you all of the HTML for all of those different pages? Does that sound like a good idea? Everybody, no! Good. So, another problem that we have with it, there's a lot of you can kind of get around the system, right? If you want, you can send requests directly to login, logout, register. You don't even have to use the index page, right? You shouldn't be able to do that. You should have to go through the interface that we've designed, right? Model, view, controller, architecture. MVC architecture is composed of these 3 major components. Model view controller architecture. You folks remember your model view distinction from Java, right? That was preparing you for this day. In model view controller architecture, we take all of our views. Views in this context are the web pages. We separate them out as their own thing. It's okay, views, you're over here. We can summon a view. We can pull up a view. Okay, that's good. Model, the quote-unquote business logic. For example, a login function. This is interacting with the database, it's making decisions about things. That's model stuff, right? So the model is all of the functions that you are sort of interacting with the website in order to perform, right? When you post a post, it goes through the model to the database. When you ask for your feed, you ask the model for a view of the database. Okay, so we know what model is and we know what view is, right? Sound good? Everybody with me so far? Good. The controller is just that. Its purpose is to connect the model to the view to the user. So, the controller is responsible for receiving packets, processing packets, deciding what model functions need to be run based on the packets that have been received. And once it receives data from the model, its job then is to pick which view is appropriate for what happened in the model. Good example. Let's say that the user makes a login request. That request hits the controller. The controller is like analyzing. Yes, this is a login request. Very good. Once we're in model view controller land, we no longer have like the name of the PHP script itself to tell us what the operation is going to be. We're going to have to do that another way, right? But that's okay. We have other ways of doing that. So in comes our login request. Controller is like, it really seems like I should send this username and this password to the model for the model to check for me to see if it's valid. See, the controller isn't interested in talking to the database, right? The controller is just interested in the end result of that operation. Is login successful or not? That's all I care about. That's all the view cares about, right? All of that business where you're like, designing SQL queries and all of that stuff, that's a layer underneath, right? So, let's say the login attempt failed. The model then reports back to the controller, that wasn't a good login attempt, unfortunately. And the controller's like, oh, it wasn't, was it? Well, then I guess you get the login page again. And so it selects a view based on what the model told it. The login was not successful, so it chooses to send the login page back again. Probably with an error message that says, username, password, combination error, or something like that. Conversely, let's assume that it was a good login attempt. The controller receives the login request, which comes in the form of an HTTP packet. It's like, analyzing, this is a login request. Model, can you take this username and password and verify it for me? Model's like, yes, thank you very much, I will do that right now. Database, can you call up the entry for this username? It's like, yeah, sure, okay, here you go. Model's like, the hash works out this time, very good. Success, that is a valid user. We are now in a logged in state, because the model is also, so the model communicates with three things, right? You have the database, like the SQL database. You also have the session. And of course, you also have the file system. So the model has three different locations that it can store data. The ones that we've been talking about over the last month, right? So the model's like, yep, I talked to the database, the login was good, I set something in the session, and to you I report, yes, this is good, we are logged in now. And the controller says, good, well then in that case I'm going to send you the dashboard page, rather than the login page, because you're already logged in. right? So it selects a different view based on what the model tells it. Does that make sense? So the controller itself, I'll stop talking almost immediately. The controller itself isn't that complicated, right? In terms of logic, it's not meant to be that complicated, right? Most of what it's doing is making selections and parsing incoming packets. After that, the logic is quite simple. Does that make sense? Okay, and we shall do some examples of model view controller architecture. We shall take this thing and convert it next time in class. Thank you very much for your time and attention, folks. You are dismissed for the day.
Thank you, sir.
Thank you.